Today we'll be covering automated drill sequences. You may ask questions by typing them in the Q&A panel. We'll get to those at the end of the webinar best we can. This session is recorded, so we can share this with you later. My name is Andy Strombeck. I'm with Technical Support. If you're new to automated drill, I recommend you guys go to our website, go to support, software, and look at our videos. We have intro to auto drill on there, and it'll get you familiar with create procedure, how it works, and just a good startup on how that works in general. We also have a video on there on thread milling and auto drill specifically, because that's where we handle our thread milling as well. Sequences allow you to fit tools and a machining process to a specific set of faces automatically. So instead of programming similar type geometry over and over and over like we do with regular drilling, this allows us to automate with a little bit of work and program incredibly fast and drill everything you need without touching all the different holes that you might have on a block. Some of the common questions we get are, do I need a sequence for each size hole? Well, that's kind of a general question that doesn't have a good answer. If we had to do a short answer, it would be yes. But really what we're looking at is specific geometry, and we're going to cover that. What are the anchors and where do they come from? We're going to cover that very shortly here. We're going to show you why you have different anchors on different geometry. Is a through hole the same as a blind hole? No, that's one common one we hear quite a bit at support. But a blind hole is going to have different anchors than a through hole on a block. It would have fewer anchors, which makes it different geometry. So it's not going to fit the same. So it's something to keep in mind as you develop these processes. Can I still post one tool at a time? Some machines require the center drill, the tap, all to be posted individually to the machine. That's not really how auto drill works, but we have a tool just for that scenario that will make that very easy for you folks to use. So we kind of talked about this, but auto drill is looking specifically at geometry, not just the smallest diameter. Two similar size holes can be considered different holes depending on the orientation in Z, and that's something that we'll look at here too. Blind versus through holes are considered different. Auto drill is designed to program all holes in one procedure. So a lot of times in regular drilling, what we have is everyone's programming a center drill, and then a drill, and then a tap, and then we have this huge list of procedures, when really, with auto drill, you only need one. So are you required to do it all in one procedure? Absolutely not. But it is the intended function, and you'll kind of see that as we go through the actual part files, how that works. So one of the common confusions, just something to kind of fit in your head right at the very beginning, is how auto drill looks at holes. In this picture, you can see these two holes appear to be identical, but really they're different. So there's different UCSs, one's pointing up, one's pointing down, and because of that, we see these seemingly similar holes facing different directions. Well, when we attach these anchors, you can see that the anchor for A on the right is different than the anchor for A on the left, and because of that, it makes them different holes. So just something to kind of keep in mind as you're developing your sequences. What are anchor points? This is something that we cover in the intro to auto drill. We highly recommend you check that before going through these sequences. But something you're going to see in every group when you're doing these procedures is the standard anchor points. So ST is for stock top. DP is for drill point up at the top here. MD is for the middle point, so the very middle of the geometry of the entire hole selection. BT is bottom point, and ST is stock bottom. Some other things you're going to notice is as you go through different holes, there's going to be more anchor points for some and less anchor points for others. What you want to keep in mind is that more geometry requires more anchor points. It's the only way for us to identify and set up tools to machine to certain levels is to add these anchor points. So you can see we go from the standard anchor points on the left, and as this whole geometry changes, we have more anchor points. So at each change in geometry, you're going to see A, then B, then C, and it'll continue as we descend down. So less geometry shape, fewer anchors. More geometry shape, more anchors. Another thing that you'll run into that is kind of something that used to be a little harder than it is right now is a breached hole. Prior to version 14, what you would see is this hole on the right, we'd have a sequence. Then we would encounter one group that was different because like on the hole on the left here, it has intersecting data that removes some of the shape, and because of that, it's considered breached. So it's different geometry. Well, before we'd have to make another sequence for that. As of version 14, that's no longer an issue. We can simply check the box to ignore breach. Then the sequence we develop for the one on the left, the one on the right, will work on the one on the left. So it's a lot less work than what it used to be. Let's go ahead and dive over to some actual part files now. We'll go ahead and get those opened up and check them out. All right, so we're going to start by just starting a new file here. I've got a couple parts for us. We're going to load a model. And we'll start with the original here. Pick a UCS. And we can turn off some of these UCSs. A little less to look at. We can go ahead and do the target part, stock. This is all stuff we can pick by criteria and actually speed this up as well. Toolpath, procedure, drill. All right, so I'm gonna knock this clearance down. We're gonna turn, we're gonna turn on the stock here. And is from watching the intro to auto drill video, you know the first thing we need to do is pick all the part surfaces, or many of them. In this case, I'm just going to pick them all, hitting Control A. Go to Group Manager. We work down this list, so I'm going to go to Group Manager, Control A, middle mouse, and then if we have sequences set up, the idea is we just hit Auto Fit, All. It found 3 out of the 4, and this fourth one is not a hole that we want programmed. So now, if I save and calculate, my block is programmed. I now have this drilled from the back and it's done, and we can move on to the next setup. That is the purpose of sequences, to speed this up and save you time. And it does a very, very good job of that when these sequences are set up right. So if we look at this and we look at the part, this is what drilling should look like. This is how fast it can be for our users. It's really a neat tool once you get it kind of figured out. So now let's actually go through and I'll show you how to make one of these sequences here. I'm going to delete this procedure. I'm going to remove one of these sequences. So we're going to make a new procedure. Control A, select all, group manager, Control A. And I'm going to go to this group right here, and we're going to say define. Again, all of this on how to set this up we cover in the first video. So we're going to define. Now, to do a sequence, the first thing we have to do is actually program this hole. So the first thing we have to do is simply get our tooling on there. So I'm going to go ahead and get a path on here. This center drill. I'm going to turn that on so I can watch it, make sure I'm not punching something in wrong here. Drill point 50, and good enough. So I can see that's not going down too far. It's not starting up too high. I'll go to my next tool, and I'll do a quick measure here. It's a 093. Okay, so I need to put in that guy right there. And then I need to display this. I'm going to go deep hole pack. I'm going to anchor to C, hole diameter, and I probably picked the wrong one here. Oh, I'm going to set that back to 0. There we go. All right. So that is one tool. We can set the pack. Not terribly important here. This decrease should always be 0 unless your machine and post are set up for it. That looks like that one's done. Let's go ahead and get our next one. Measure this. 156. Okay, let's grab that guy. Let's make sure we're not going too deep. We're going to anchor to A. And that looks good. Not terribly critical in this application. We'll go that. And okay. Now, this 062 at the bottom here, that would wander if we tried to drill it, so you'd probably wire that or drill it from the top. So that's something we're going to leave alone. In this case, we're just doing the back drill. So now here comes the sequence part. I'm going to have other core blocks that have this same type of back drill. They just might be shorter, different heights of block, things like that. But the diameters are going to be the same. So why would I program that every single time? Well, with sequencing, you don't have to. So that starts up here. Now that we have our tools on, we're going to go to this geometrical data. We're going to hit the expand. And you can see we got a lot of info here. Now, this information is not related to the tooling down here necessarily. It doesn't affect if it works. This is applying to this geometry. So when we try to auto fit on other blocks, it knows, hey, look at this information and figure out if you should be cutting it. So if we set this up right, it should cut many different parts, even if the geometry is slightly different in, let's say, length, but not necessarily size. Or if we set up ranges, it can be different size and length. So what we'll do here is we'll start at the top. So the ST anchor, the height, and the nominal size. Now, in this case, the default is a range, which is fine. You don't have to use that. But in this case, I'm going to leave the range. I'm going to use 0 with a max of, let's say, 200. So if there's another block that maybe hasn't been face down yet or something like that, this sequence will still fit in and adjust for that stock that is left on the part. It's a really nice feature. Now this A top diameter, the 156 here, is this top cylinder. We want that to be, we want the sequence only to fit when that diameter is the 156. So we leave that on fixed. Our options are fix, range, and NA. So in this case, that one we want fix. Then the height of that cylinder, we want a range, right? Because if the next block is 3/8 of an inch shorter, this won't fit if we leave that range here to here, right? or leave it on fixed. So we need to give it a window to work in. So I'm going to put a minimum, in this case, of 200. It's just what I like. It doesn't mean it's what you have to use. So we're going to set that range for this top cylinder height. The next thing you see here is B, all of these, B. Now, in this application, the B is the angle, this chamfer diameter and this chamfer angle between the two cylinders. I see a lot of customers who are trying to do sequences and maybe the designer changed this a little bit on them or used a different pin that cut with a slightly different angle for some reason. You have two ways of handling that because it will prevent the sequence from working. We can set a range on all of these options for B, or we can tell it just to ignore it. I mean, if that angle is slightly different, I really don't care. It's not important in this situation. What really matters to me are these diameters, that those are the same. So for the chamfer between them, I'm just going to say NA. Why sit here and fight it if we don't have to? And that's one of the more common things we see with customers is trying to over constrain things when they're making these sequences. So you don't want it loosened up so much that it works on everything, but you don't want it locked down so tight it can only work on one hole ever. So what we do, we're going to go ahead and in this case, this will work great just taking those off. Now we go to the next diameter, which is C here. We're going to leave that on fixed again because that's a diameter that matters. We need that. Now, if you have a customer, let's say your design is outside of Cimatron, you're bringing in files from another software. This might not be a good option for you if you ever have a problem with data. So maybe your diameter range would be plus or minus half a thousandths. That's an option and it would allow it to work if you had a slight variation. Now, is it a great option? I'm not sure. I think I'd rather have it fixed, but if you need that, it's there. So we're going to go back to fixed. See height. The height of that tube, again, if it's 773 to 773, this sequence does nothing for anyone. It's only good for this application. We don't want that. We're tired of programming the same thing all the time. So let's go ahead and get this fixed up. And see, tube diameter is done. Now we're on to this slight angle transfer from one to another. Again, it's not critical for getting this the way we need it. So we're going to ignore it. So now we're on E, this lower diameter. We're not going to drill this because this diameter, 062, over that length, it would wander. It'd be no good. You'd probably wire this or drill it from the other side. But we do want this sequence to fit on exactly this type of hole, right? An 062 pin drilled from the back. So we need to reference this diameter to have it come out right. So we're going to leave the diameter fixed. We're going to set the range for the height. But again, we got to change this. I'm going to do 200 minimum, which it would never be that little. And then I'm going to do 150 max because at that point, honestly, the tooling's not even going to reach. But we're looking at geometry. It's not about just these tools. So we now have this info, geometrical and sequence table info set up. This is going to affect all of our sequence working in the future, which is why this is so important to set it up right. So now I'm going to go ahead and give this a name. We're going to call this 1/16 pin, if I can spell, back drill. Okay. So what we do, once we have that name, we're going to come down to save sequence. It's in the middle of the left side of the screen here. It's got the little save disk. We're going to hit that. And it gives us this option, just like NC report, to make a picture to go with this sequence. So if you ever load a sequence, which we're going to cover in a little bit here, you can see a picture to go, oh, you know what? This one looks like what I'm trying to find. And you can set that up. It's easy to pick. So now that we have that, we're going to hit the small green check. We're going to save this. Green check. Save and calculate. So now we've gone ahead and it's drilled our holes. Now, since we just made that sequence, we can actually, delete this, create it again. And this is a good way to test the sequence that you made if it's any good, because if you miss something, it may not fit. If it doesn't fit on what you just had, then you definitely got a problem. So we'll just pick all these. Route Manager, Control A, Auto Fit, green check, OK, save and calculate. We have a part. That setup is done. This is what drilling should look like. It should be quick. And if you take the time to program it once, why not take the time to program it for future applications? Now, another thing we'd like to show you guys that you'll run into, let's say your designer sends you this block back. The block is slightly different thickness, maybe he's got more pinholes. Let's take a look at what that looks like. We're going to go ahead and load that model, but update it. It's got more pins, slightly different back drills. There's a few things changed on it. Clean up these UCSs. Okay, so we can see there's more pins than there were before, and these are slightly different back drill depths than what we had before. The designer made some changes here, so we're just going to go ahead and get this set up. Go here, here, get our tool path, get our procedure. Sorry, drill, auto drill. And again, this would all be templated and grabbed by criteria. We wouldn't usually sit here and pick through this. We'll set our stock to use. Grab all of these. Grab all of these. And again, we're just going to auto fit because I don't want to sit here and program more than I have to. I might not have everything, but why sit here and work harder than we have to? So 3 out of the 5 groups, a sequence was found. Let's see what was missing. So if we go to here, this is the ring on the other side, which isn't really a hole we would do anything with in auto drill. The other one are these 4 holes right here. Now, this is where we find some folks get a little confused or frustrated because this hole is the same as this hole. There's just a chamfer on it. So it's technically not a breach. It's not a partial interruption. That chamfer goes all the way around. It makes it different geometry. So do I have to really sit here and reprogram the whole thing? Not really. What we can do is right click over here and say define, right? So this looks very similar to what we had. Well, I know I have a sequence like this laying around. I can come over to the left middle side, choose load sequence, and I can click through these and I go, okay, that's definitely not right. That's not quite right. Well, this one is. That looks pretty good. So I'm going to go ahead and just say, you know what, put it on there. And it warns me that the geometry is different, so it can't anchor up the way that it did before. That's fine. We're not worried about that. I want the tools, right? So now I can put this in. Now I'm going to check that drill. I'm just going to send that back down, but I'll get it to the right depth. So let's go D. That looks good. And then let's go to 156. Let's get that one going to B. And that looks good. Now, here I can either add another tool to do the chamfer, or we can just call it good and save it. Either way. So I'm going to go ahead and throw a chamfer tool in here. And go spot drill. Let's go to drill point. And we don't want full diameter, that's for sure. All right, so now that we have that back in there, we've added a chamfer for this different geometry. We've saved time by just loading a sequence. Well, what we can do is I'm going to come up here to the name. I'm going to call this chamfer on the back. So I know it's the same thing, but just with a chamfer tool. The naming conventions will be different between all of you. It's really whatever makes sense and helps you organize it in your mind, whatever makes the most sense. We're going to go ahead and we got to check these before we resave. Always check your sequence info. I can see that this is not what I want. So I'm going to go ahead and fix this. So this A, again, this is a chamfer. It's not the defining feature. I do not want that affecting this fitting. I do want these cylinders affecting it. So B top 156 looks good. I'm going to go here to max 1.5, and then I'm going to go back to the chamfer again, not holding me up. Range 0.2, 1.5. Okay, and then we're back to our little chamfer area. Then we're back to the diameter, the 062, which we want to recognize. Okay, and then we're ready to save. So I'm going to fit this in there so I can see it slightly different. Green check. Save it in here. Now, this is going to go ahead and cut this block, drill this block, and give me everything I need. If I were to remove this or run into another block similar again, this would do the work. So grab this, Group Manager, Control A, Auto Fit. Yes. And I've just done the back drill. So these sequences can save an incredible amount of programming time. You're already going to program them once. So putting a little bit more time into setting them up is really, really worth the time. And it's something we're figuring out. And hopefully this video will go ahead and show you guys a way to get started with that. Let's see here. Another thing we want to just point out to you guys, something that we see, let's say for some reason you wanted to go back and do, like maybe you wanted to mill a little of that hole to center it up or something. If you create a second drill procedure, let's say you didn't want to do everything in one procedure. Notice all my part surfaces are picked. And when I go to Group Manager, I can't pick anything. If you look at this block, all the holes are gone. Well, the system knows that you could have and did do these holes, or at least pick them in groups in the previous procedure. So why would it put them here for you to keep drilling the same thing over on a large part that could create a lot of work picking through things? So what they do is they recognize that it was drillable in the previous hole. If you want to drill them in the second procedure, we want to go over to the automated drill tree on the right hand side here and notice this drilled holes feature. If you display drilled holes, all of these show up and you can window pick them for your group. But if you don't display the drilled holes, you cannot pick them. Now, one other thing we wanted to quick show you guys today, for the folks that have to post these one at a time, what you can do is highlight your procedure, go up to NC Edit, go to Other, Divide by Procedure. Now notice it takes my main procedure and it shows that is not calculated, but really they're all split out down here. So all of this, your center drill, your drills, you can post these all one at a time. The only thing you got to keep in mind is if you want to change something, you have to do it in the main one up here. So what you want to do is just take all of this, delete it, edit your auto drill, your main, make your change, define your sequence, modify it, make your change 40, green check, save and calculate. And for anybody wondering about that pop-up, you will know what that is after watching our intro to auto drill procedure video. But now we just come back up and see it at other divide, and you have all of these split out individually again. So for folks doing water lines, pin drilling, really any of this stuff, the depths may be different each time, but really you're always going to cut 8mm taps to hold your block in, or you're going to do 16th pins, quarter pins. All this stuff is redundant, and that's what sequencing allows you to do, is fit to that geometry. And even though it's slightly different each time, your sequences will mold to it, adapt, and program the block for you. And the goal is to reduce time with this, and it does a really, really good job of it when your sequences are set up correctly. So if you have any trouble or questions with it, always feel free to contact us at support. We're happy to help and fine tune this. And there's a lot more here too, guys, that we haven't covered. We're doing what we can with this time, but there is manufacturing attributes that help identify if you have 2 1/4-inch holes that are identical, but let's say one's going to get wired, one's going to get reamed. We can identify between those holes from the design process, and we even have tools to let the designer verify they're doing holes correctly before they even reach the NC guys. So we have a ton of functionality here. We're happy to help at support. We'll go ahead and open this up to questions now. Thanks for your time.